Hello everybody, welcome to Chapter 9. Chapter 9 is one of the core chapters, core ideas for any chemistry class, especially Chem 51. All of you are going to be dealing with solutions. So I'm breaking this up into 2 weeks, which is not perfect, of course, none of this is. So these two sort of sections make sense to talk about sort of definitions and terminology, and then maybe talk about what's going on here in terms of intermolecular forces and the thermodynamics, the enthalpy and entropy here. Those go together nicely. And then we have this sort of lump that's really important. Some of the most useful information in terms of practical information, that's it. And then we have this sort of some other interesting things, of course, going on. So we're going to spread this over 2 weeks. I'm going to do this week, and then I've also added 98A. That's a recitation exercise set, but we will not have a quiz. So the time you would have spent maybe studying for the quiz and taking the quiz, instead you'll work on 98A. I hope that is going to work. All of this is kind of, it's difficult to understand how in this format it all fits and how much time it takes and what should be split up. But anyway, Chapter 9 is too much to do in 1 week. It's very important. So I'll spread it out over 2 and wish me luck. Okay. One other thing I wanted to mention is, with each of the lecture videos, I tell you where in the book, what sections of the book. And I believe the people that are doing really well are also reading the book. Even if you just skim it, kind of get a few ideas before the lecture. It's very difficult to get a whole lot out of these weird one-way recorded lectures that are not a conversation, that are more productive and, quite frankly, a lot more fun. All right. Now, remember I've been saying this since January? Here's everything that we're going to look at in that Chapter 9, and it brings up about 5 or maybe 6 chapters. Now, the good news is, because of this wacky semester, we're going to do very few calculations, so we can cross that off. But still, you can see, gee, I better be able to recognize acids, ionic or molecular, polar and nonpolar, sort of fundamentals from Chapter 3 and 4. And then Chapter 5, similarly, well, we should probably know our solubility rules. And then, as I mentioned, there are some enthalpy and entropy and Gibbs free energy things to talk about. Really not much math, but very interesting to tie these things that we already know into something new, and it makes sense. I love this stuff. And then a little bit we want to talk about pressure, mostly vapor pressure. Okay, you've been warned. This is the big chapter. Let's put our thinking caps on here. Now, I've got 2 sets of examples. I've got example set X and example set Y. Now, these are both mixtures. They're both mixtures. But I would group this set together and this set together. They're really 2 very different types of mixtures. You might stop the video and look at those and look at those. Say, gosh, why are those together? Why are those together? Why are they 2 separate groups? Construction management people, here's your chance to shine. Portland cement versus concrete. The general public doesn't know the difference there, so you can help them out. So take a minute, think about that set, maybe do the description. Stop the video and do that. All right, I'm sure you spent several hours thinking about this, having a rousing online discussion. So if I look at this, chocolate ice cream, seawater, hot tea with sugar, Portland cement, I mean, one way to think about it is, just in very informal terms, is that appears to be sort of smooth, appears to be one substance. That's not what it is, but that's what it looks like to us. Over here, Rocky Road ice cream, I see chocolate ice cream, marshmallows, and walnuts. Wet sand, well, there's water and sand. Tea with ice cubes. very obviously appears to be more than one thing. So here's our silly informal term. We'll say that's chunky. And it's obvious that there's at least two things in there. So I'll say obviously greater than or equal to two substances. Now, we can get a little more formal. Say, okay, this stuff. Imagine this. You've got chocolate ice cream and Rocky Road ice cream. I'm going to go in with tweezers and take very small samples of the chocolate ice cream. Or maybe a little syringe or something, and just take a small sample. Well, all small samples of this set would look the same. If you take 100 samples, teeny tiny bit, the amount that would fit on the head of a pin, all samples are the same. However, if you think about the Rocky Road ice cream, you might get ice cream, you might get marshmallow, you might get walnut. So we could say, well, small samples are not always the same. Again, you could get a chunk of nuts, you get a chunk of marshmallow, you get a chunk of ice cream. So small samples aren't the same. The other thing is, what if I gave you Rocky Road ice cream and I said, okay, and obviously there's 2 or 3 or 4 things in there. Could you separate them? Could you go into your kitchen and separate them? Well, if you have a strainer or a sieve, let's say strainer. I wonder what word people use most commonly. You know, that's the thing. You rinse vegetables and the water goes through. A strainer can separate the substances or the components or the constituents, whatever you say. Like, so the fancy way we say it is, well, we could mechanically separate this mixture. This mixture, you can pour it through a sieve, through a strainer or whatever. Nothing happens. You get the same stuff out. Now here are the technical terms. This smooth stuff that appears to be consistent, appears to all be one thing, we call a homogeneous mixture. This stuff that appears to be different things, we say, is a heterogeneous mixture. Now, this is in general not what we would study in Chem 51. That's more of an engineering or applied thing. This is what we're going to study in Chem 51. And by the way, we are never, ever going to call it a homogeneous mixture. Ever again. That's the technical term. We're going to call this a solution. We go, okay, homogeneous mixture is a solution. Heterogeneous mixture, we separate it out just to be able to differentiate, but we're really not going to do anything with it. There's one last thing in this sort of introduction to solutions, and that is I'm going to separate. This is literally a sample of Coca-Cola, 111 grams. Maybe that's the amount in a bottle. That doesn't sound right. I don't know how come I had a 111 gram sample. But I'm going to separate it into this and this. Now, this stuff here, all of these, I'm going to call, let me get a better color pen. I'm going to call those things the solute or the solutes. I'm going to call this thing, find the blue pen, the solvent. Now, even if you don't know what that means, it's fine. That's where we're going. There always can be more than one solute. There will only be one solvent in a solution. Now, you might stop the video and say, well, wait, what do the solutes have in common? What does the solvent have in common? All right, you stopped the video and thought about that? Okay. So if I look at these 4 things that are there, the thing that there is most of is water. Out of 111 grams, I've got 100 grams of water, and roughly then 11 grams of the solutes. So sometimes we say like the major constituent or the major component or the largest percentage. Let's say the major component, So we'll say, well, that's the largest percentage we call the solvent. And if you might guess, for Chem 51 and what you're going to see in the real world, often that's just water. Biological systems, agricultural systems, water, water, water. Construction, preparing solutions with water. So that's really what we're going to mostly focus on. The minor component, the smaller percentages, we call the solute. And yeah, let's just leave it at that. When we look at solutions, hey, there's mostly this, we're going to call that the solvent. Oh, there's less of this, we're going to call that the solute or the solutes. And when we use the word solution, we mean the solvent plus the solute. Okay, so that concludes a sort of introduction. What's a solution? What are the terms we use? The next thing we're going to talk about is, well, how do solutions form? What intermolecular forces are associated with that? We're going to talk a little bit about solubility. And then the last part of this week's lecture, we will get into concentration. So I'll see you at the next lecture segment.